Hi everyone, my name is Julianne Albion. Today is June 6, 2020. For Chemistry 1, we'll be doing Advanced Interactive Concept Presentation 2. And this is like the lava lamp that we'll be talking about. So first, I'm going to tell you my hypothesis is that the oil and the water will not mix together, and that they will stay separated because of the oil and the density of the oil and the water. So here's what you need. I have a whole bunch of my stuff out here. So basically, we're going to need a clear, empty bottle. For the sake of this video and for the presentation, I just kind of peeled off what was some kind of water soda bottle. Then I have some oil. I already opened it just to have it all ready so I can show you. Some oil. And then I have some water. My Alka-Seltzer tablets over here. Just open that up just a little bit. And then I have just, kind of food coloring. Just a bunch of different colors in there. I'm probably going to use the blue one because that's my favorite color. So basically, I'm going to fill about 1/4, so I'd say that's about 1/2, just that's a little bit smaller, so about half, so about 1/4, so I'll probably fill up just about that much. So I'm going to go ahead and fill that water up over here, move my camera so you can see, fill that up, so it was about 1/2, maybe like this much water. It's good water. Okay, now I'm going to pour some vegetable oil. Now, I guess this may or may not be the source of most of my error, but I'm going to fill up a lot of it, and I really, really hope I have a lot. Almost the entire rest of the container with the vegetable oil. I don't have vegetable oil, so I used extra virgin olive oil, and I really, really hope that it still gives the same effect. I'm not sure if that's enough. I don't think that's enough when I did it before, but we'll see. Trial and error, right? So now I'm going to put, so I had to leave just a little bit of space on top. Now I'm going to put about 8 to 10 drops of the food coloring. I don't have any glitter, but I'm sure that would be really pretty, so I guess we're going to count out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I picked the number in between. So you could start to see that the oil and the oil is all on the top and the water is on the bottom. And it's really cool if you can really look in there. Not sure if you could see it, but it looks like kind of just like bubbly beads of color. Okay, next I'm going to break a little bit of pieces of the Alka-Seltzer tablet. It actually kind of already broke, so that kind of works. But before the Alka-Seltzer is dropped in the bottle, the oil floats onto the colored water. The oil floats because it's less dense than the water, and the oil and the water don't mix because the molecules are not attracted to oil molecules. So this will show you a lot of density. The idea is that there are more dense than a liquid. Things that are more dense than liquid sink, and things that are less dense than liquid will float. And this activity is really interesting because the gas is added to and taken away from big drops of water, which changes their density and causes them to sink or float. So as you can see, once the Alka-Seltzer tablet is dropped in, it'll sink because it is more dense than oil and more dense than the water. See, so it starts to go up, and here we have it. Oh, sorry, didn't realize. And that's really cool. So this usually happens for about 5 minutes. As you can see, now all the color went down to the bottom, so now the color is starting to happen. In the water layer, the tablet begins to dissolve, just like I said, and the chemicals in the tablet react with each other and create like that bubbly sensation that are the carbon dioxide gases. Oh my god, it's so cool, look at that. So when enough gas enters a part of the area of the water and gas combination will become less dense than the water around it. So it will float up through the water, thus giving it that beautiful lava lamp look. So I guess it really didn't matter. So really all the interaction happens within the oil area. Let me go ahead and see what happens if I add another one. So the water is attracted to the self and not the oil. So the water and gas mixture will move through the oil in a ball type shape. Wow, that's a lot. I actually don't even think I need to add a whole other one. Anyway, okay. So I wonder what else could work. So because I didn't use vegetable oil, I wonder if that's a source of error for me. Because I did use I used extra virgin olive oil. Maybe there could have been more of an effect, or actually maybe less of an effect, because it's such a small bottle, it would have been able to kind of spread out a little more. So, because as you can see, it kind of just looks like a whole bunch of cool balls in there. That's a really cool part. So I wonder if you mix it all together beforehand, would it become like one big mixture? Probably not, because still density is the same whether you mix it or not beforehand. Maybe the speed of how you mixed it, the pressure and such. And also, because, like when you have a real lava lamp, you end up like, not the right cover. You end up putting it like by a you end up putting it by a lamp. You end up plugging it in like a lamp. So I wonder if I were to put this like under a light inside a dark room where the blue kind of come out more. And maybe if I didn't have enough ingredients, like I said, would that have changed it? Probably not. I don't think that it really changed it that much because I was still able to follow through with the whole thing. Really cool experiment. Probably gonna show a lot of my friends how cool this was. Yeah, fun chemistry. Thanks, guys. Enjoy.